sklearn, linear model, gamma regressor. Description: a gamma regressor model in scikit-learn is used to predict the target variable using a gamma distribution model, which is a continuous probability distribution that is frequently used to model positively skewed data. It is particularly suited for scenarios where the target variable is non-negative and exhibits a positive skew. Inputs: X. This is the input feature matrix. A 2D array where each row represents a data point, and each column represents a feature. Y. This is the target variable. A 1D array representing the values to be predicted. Outputs: model the trained gamma regressor model. YPRED the predicted target values based on the trained model. Steps: initialization: a gamma regressor object is created with desired parameters. Training: the model is trained by fitting it to the input features X and the target variable Y. Prediction: the trained model is used to predict the target values for new input features X. Metrics: mean squared error. MSE measures the average squared difference between the predicted and actual target values. Root mean squared error. RMSE represents the square root of the MSE and provides a measure of a model's prediction error in the same units as the target variable. R squared indicates the proportion of the variance in the target variable that is explained by the model. Mean absolute error may calculates the average absolute difference between the predicted and actual target values. Visualization plots: residual plot shows the difference between the predicted and actual values, helping to identify patterns in the model's errors. Scatter plot displays the relationship between the predicted and actual target values. Fine-tune parameters: alpha regularization strength that helps prevent overfitting by penalizing large coefficients. Fit intercept determines whether to add an intercept term to the model. Uncertainty methods: confidence intervals provide a range of values within which the true target value is likely to fall, based on the model's uncertainty. Challenges and fixes: Challenge 1: overfitting. The model might overfit the training data, leading to poor performance on unseen data. Sample use case that resulted in challenge 1: when the training dataset is small and contains noise. The model might learn the noise instead of the underlying patterns. Fixes to challenge 1: increase the regularization strength alpha to penalize complex models and encourage simpler ones. Use cross-validation to evaluate the model's performance on unseen data and identify potential overfitting. Challenge 2: data skewness. The gamma distribution is typically used for positively skewed data. If the data is not skewed or has a different skewness, the model may not perform well. Sample use case that resulted in challenge 2: if the target variable is evenly distributed or negatively skewed, the gamma distribution might not be an appropriate model. Fixes to challenge 2: consider alternative regression models that are better suited for the specific data distribution. Apply data transformations to make the data more suitable for the gamma distribution. Use a different regression model that is better suited for the specific data distribution, such as a linear regression or a generalized linear model (GLM).